Hey, okay, today I'm explaining number 33 from the chapter 9 problem set. So the problem states that a particle of mass 17 times 10 to the negative 27 kilograms bursts or blasts into three different particles of different masses, each with different velocities. So the first two are stated. One goes 5 times 10 to the negative 27 kilograms goes 6 times 10 to the 6 meters per second as a velocity in solely the y direction, while the second one goes 4 times 10 to the 6 meters per second in the x direction, and it has a mass of 8.4 times 10 to the negative 27 kilograms. Now the third one, we know its mass is, of course, the original mass minus the other two masses, so we get 3.6 times 10 to the negative 27 kilograms, but we do not know what velocity it has. But with the conservation momentum, we know that it has to add with the velocity in the y direction to make 0 and the velocity in the x direction to make 0. So we're just calculating the velocity for that mass with equal momentum to both of these to cancel it out. So plug in for x, we call momentum of in the x direction of particle 3 equals momentum of the second particle. Just plug that in, cancel out, go through the math, and you get negative 9.33 times 10 to the 6 meters per second. It is the velocity of the third particle in the x direction, regarding, of course, x is in the positive direction of right and y is in the positive direction for vertical. So then for the velocity in the y direction, we do the same thing except with the momentum of particle 1. So m3 vy equals m1 v1. So we get vy by itself, just plug in, and you get negative 8.33 times 10 to the 6 meters per second in the y direction. So you get the component velocities of just what was stated earlier, and then by taking the square root of this squared plus this squared, you get the directional velocity, which is 1.25 times 10 to the 7th meters per second. Of course, this is the answer to this problem, but you need this for the next part, which is the increase in kinetic energy. So since it had a velocity of 0 at the start, it began with the kinetic energy of 0. So all the kinetic energy from the three particles and their velocities, that was all added on. So we just calculate that. Just using regular kinetic energy formulas for the first particle, second particle, and the third particle. Just solve that out. Plug in. It's a lot of work on that part. And you just get 4.38 times 10 to the negative 13 joules. And just a little overview. That's it.